next one is exploring state space. And so with the exploration, I feel like there's kind of this like cartographical implication and sort of travel. And to me, that sort of hints at tripping. So is this kind of almost like the art of pharmacology in some respects?
Well, that would be one instantiation of it. I mean, I think definitely exploring weird drugs and combinations of drugs, and it's a pretty effective way of exploring the state space of consciousness. It's also pretty dangerous unless you really know what you're doing. And that's why, like, I mean, a more kind of a simpler example would be exploring combinations of sounds. I mean, definitely exploring the state space of rhythmic patterns. It's a very interesting thing because, and actually I think like really profound, because you're basically exploring in what way you can make internal metronomes get activated and then clash against each other in a consonant or dissonant way. And that's a super interesting line of research. But it also shows up in things such as like exploring the state space of sense. You know, you're gonna have this article about the perfumery as an art form, and you know, you can also apply the fifth model, exploring the state space of consciousness, to perfumes, and that one would suggest an aesthetic such as, like, no, don't focus only on like, oh, this is a mysterious smell, or this is a very erotic smell, or these traditional things. Think more about like, oh, this smell is an instance of this region of the state space of consciousness that I didn't know about. And you have kind of this craving for knowledge of what is in the entire state space, and almost kind of a frustration with artists who are just stuck in a particular region of the state space without like trying to explore further. And of course, it's related to the first model in the sense that a lot of that aesthetic is about pushing the boundary, but it's in a sense more comprehensive than the first model, because the first model is just almost kind of like trying to troll all the time. It's like, oh, I bet you didn't know this was also possible. Whereas the state space actually is pursuing clarity. It actually is pursuing like, hey, we would all benefit if we understood what is the range, the scope of what's possible. And, you know, I personally find very beautiful when an artist is kind of systematically exploring all combinations, and then they come out and say like, well, we did all the combinations, and maybe only these ones are interesting, but hey, at least we tried the other ones. Like, we just didn't ignore them.
And so in terms of like something like flavor space, you're, you know, exploring all these different combinations of bitter, sour, and like I saw your Twitter poll today about how we perceive sourness, and like I think that's an interesting thing, because I mean, it's not a great flavor usually, but like part of me does want to explore every avenue and then sort of, you know, prune away the shitty ones. Yeah,
exactly. And a lot of it has to do with not prematurely closing possibilities. I mean, like, consider like dissonant sounds. Like, if you're just starting out in music, you may just avoid some sounds, but then after a while you can revisit them, and it's like, oh gosh, I could actually use this as a building block, and you're exploring a space that didn't exist before. I would say perhaps a last example of this would be in the realm of like plastic arts, that there's this innovation in basically metallurgy called high entropy alloys, because it used to be the case that most of the alloys explored were, let's say, like 90% steel and 1% something else, you know, usually carbon, or it could be zinc, or, you know, bronze, or something else. But like it would be like the bulk of it about one material, then a tiny bit of something else. Whereas high entropy alloys are defined basically as any mixture of metals that has like 5 or more different metals, and all of them in high proportions, like let's say more than 5% of each of them. And that's an insanely large combinatorial space. You know, there's like roughly, you know, like 30 different metals you could use in a practical way, and just like all the combinations with all of those properties, and it's largely unexplored. We know very little about that combinatorial space. Chances are there's some amazing art to be discovered in some of those regions.
Now, so are you about to have 2 metallurgy references in this conversation?
Oh, sure. Yes, that's right.
Cool. So why don't we get to energy parameter and neural annealing and all that?
Yes. Yeah. So, well, I guess those are the next two. So yes, the energy parameter, I mean, that's recognizing that, I mean, if you analyze, okay, how do people actually use art? To a large extent, you can think of it as a way of modulating their energy levels. And I'm not talking only about like, like drinking coffee or something like that, because that has more to do with like arousal and like energy. In the way in which I'm talking about it here is a more general concept. And you can have, for example, very energetic, relaxed experiences. You can have like these, what's called like a Buddhist jhanas, these states of high concentration. They can be very peaceful. At the same time, they're like very high energy, which is, interesting that it's even possible to combine the two. Or MDMA, MDMA causes this feeling of deep calm, but it's also like energizing. They're not mutually exclusive. And basically, most kinds of art, they tend to be popular if they are effective at raising the energy of the people who consume it. And also, you would generally be people gravitate towards art that increases their own energy. And there's a lot of idiosyncrasies in there. But then, okay, so how do you actually raise energy? And this is really where like, a scientific model of art becomes very possible, because you would look in neuroscience like, okay, what are energy sinks and energy sources? And you can think of, it's almost kind of, your brain is a dam. You have water coming in and water coming out, and how filled up you are is basically the balance between how much is coming in, how much is going out. And to raise the energy parameter, you can block energy sinks or increase energy sources. And this, I think, explains quite a bit, like, for example, the power of things like modern art, because one of the energy sinks that exist is basically, I mean, people who read, I guess, Less Wrong might be familiar with this concept of energy, like a Bayesian energy sink, that like whenever you recognize something as very expected, that is almost kind of an anti-surprise, right? It's kind of like a letdown. It very quickly cools you off. It's like, oh, that's perfectly expected. So you kind of your mind tunes it out. In a sense, your mind is only allowing the things that are surprising to come up. And therefore, when you remove any sense of familiarity in a given context, when you enter an art gallery and they say, oh, you have to, wear these special shoes and these glasses and these strange headphones, and all of a sudden everything is completely unfamiliar, like that will cause a spike in energy because you're accumulating surprises. Everything is slightly surprising in a strange way. And another way in which you can also do it is more straightforwardly increase energy sources. So, obviously like flashing lights and very loud sounds and body vibration, and all of those are like a way of like overwhelming the energy sinks. And of course, like psychedelics are like a very, very effective way of increasing the energy parameter. And I would say there's a very deep reason why psychedelics are associated with art so deeply. They just increase the enjoyment of art more broadly. Well, yeah, I guess that's like model number 6, and it connects to number 7, because number 7 goes into this theory we call neural annealing, and this is the second metallurgy metaphor, where basically when you have like a metal and you use it, for example, to bend things, like or for example, use a sword a lot, or you use like a component of an electronic material. Eventually it gets what is called cold worked, which is like a lot of like little imperfections accumulate into it, and it becomes brittle, becomes less functional, it's easier to break. It just doesn't serve its purpose as well. And something that you can do is basically reheat it above its recrystallization temperature. And this happens actually even before it melts. Like you don't actually need to melt the metal as such. You just need to heat it above a threshold. And then the atoms will start to basically reorganize such that if you then cool it down very slowly, they will all of them get aligned perfectly into this geometric lattice, and it's going to be a lot more smooth, and it will have like a lot very nice properties like ductility and strength simultaneously. And likewise, we basically in our model, when you raise the energy parameter above a certain threshold in the brain, and you keep it at that level for a while, it will first start to melt kind of your pre-existing patterns, what in neuroscience they're calling entropic disintegration. And later on, if you cool down slowly, you will reorganize into a much more harmonious and consistent pattern. I mean, and I say consistent actually in two senses. First, in an emotional sense, like you will have relieved a lot of inner tension. And second, also in a cognitive sense, because when you're stuck with a problem that is very hard to solve, by raising the energy parameter, you can explore many possibilities very quickly. And then cooling it down, you will basically crystallize a solution that satisfies many constraints. And that technique is used for computation in, like, for example, simulated annealing, which is a computational tool. So, I mean, I don't find it that surprising. I mean, it's obviously amazing, but it's kind of expected that a psychedelic might be helpful if you're really stuck in a problem, whether it's emotional or cognitive. And likewise, really being hit very strongly by art will have the same effects.